All right, guys. So um, this is just going to be kind of a little mini unit on the graphs of trigonometric functions. All right. The two that I'm going to focus on the most are sine and cosine. All right. Um, Honestly, those are the only two that are really that important. Um, I guess the other graphs have some use somewhere ever, but seeing as how I have an actual degree in applied mathematics and never used the graphs of any of the other ones for my entire 4 years of taking nothing but math classes in college, I'm going to say they're really not all that important. However, sine and cosine are used all the time in various sciences. You will see sine and cosine often, so that's why I'm going to focus much more heavily on those. Okay. All right. So first, let's go ahead and create a table of values, right? That's what we do when we graph things, all right? So this is going to be from the unit circle, hint, hint, wink, wink, especially now that we're all together. Unit circle quiz will be imminent, all right? So make sure that you are ready for that, all right? But anyway, you should have one handy. Yes? Question? Yes. Yep, I will be. I want them to be up there for anybody who's quarantined. I definitely have some people on homebound. So there's still some people that won't physically be in class. So this is just the easiest way to go ahead and let them have access to everything. And of course, if you are unclear on something and you need to go back and watch it again, then you'll have access to it. All right, so we should all have access to a unit circle. All right, there's also one hanging in the front of the room. All right, so the sign of 0 is 0. The sign of pi over 2 is 1. The sign of pi is 0. The sign of 3 pi over 2 is -1. And the sign of 2 pi is 0. All right, so that is all of our kind of main points. All right, so if we graph this, all right, so here we can say that this, of course, the origin is 0. All right, this will be pi over 2. This would be pi. This would be 3 pi over 2. And this would be 2 pi. All right, so if we go ahead and graph these, of course, we have the point 0, 0. We have the point pi over 2, 1. Pi, 0. 3 pi over 2, -1, and 2 pi, 0. All right, so if we connect these with a nice smooth curve, no. All right, it looks something like this. All right, now this is just one period, all right, of sine rather, right, from 0 to 2 pi. All right, so remember, trigonometric functions are periodic, which means they repeat themselves over and over and over again. All right, so if I took this, I could bring it over here, right? And this would be -pi over 2 here. This would be -pi. This would be -3 pi over 2. And over here we would have -2 pi. Right, of course, you could do it again. connected over here. Right, so this would be 5 pi over 2, 3 pi, so on and so forth. This would go on forever and ever and ever. So this is the parent function, just sine of x. Right. In this case, when we say sine of x, you can say sine of theta, right, because we're really plugging in the theta. Of course, when we think of things as x comma y, it's hard for us to think of them as theta comma y. So sometimes it's easier to just think of them as x and y. But that's it. That's our parent function. All right, and now we're going to talk about how these things can get more and more complicated. All right, but before we do that, we'll go ahead and talk about the features of this graph. All right, so we have the domain. The domain is the x values. All right, is there any x value that I'm not allowed to put in here? No, right? It goes forever to the right and it goes forever to the left. All right, so my domain will be all real numbers, or negative infinity to infinity. All right, going back and looking at our parent function here, what is my range? What's the lowest this graph goes? What's the highest this graph goes? -1 to 1. All right, and it is inclusive. So we say the range is -1 to 1. And we talked about this a little bit when we first talked about inverses a couple of weeks ago, right? We had to kind of look at this graph and then cut it so that it would pass the horizontal line test. So some of this should be a little familiar. All right. The period is how often it takes before this thing starts to repeat itself. So if I start at 0, how long do I go before it just starts the exact same circle over again? Well, kind of, right? 4 hash marks, but what is that actually on my x-axis here? 2 pi, yeah. Period of sine and cosine will be 2 pi. All right, now this is kind of where it gets funky, right? X-intercepts, right? Well, where does this thing cross the x-axis, right? Well, 0, pi, 2 pi, 3 pi, negative 2 pi, right? And it would keep going forever and ever, right? So how can I kind of include an infinite number of x-intercepts here? We say, okay, well, this is 0 plus or minus n times pi. All right, and what that means, n is just any natural number, any counting number, right? So 1, 2, 3, 4, 5, all right? Well, if I add 1 pi, I get here. If I were to add 2 pi, that would count this one. If I were to add 3 pi, it would be the one over here, right? If I were to subtract 1 pi from 0, I would end up here at this x-intercept. If I were to subtract 2 pi, I would end up here at this x-intercept, and so on forever and ever in both directions, right? So this actually covers all infinite x-intercepts. What is the y-intercept? Somebody said it, I think. 0, yeah, absolutely. And you can put it as a point if you like, 0, 0. It's perfectly fine. Right, now, is this even or odd? All right, we've actually talked about even and odd functions. We talked about them both graphically and algebraically, and then we also just did the even and odd trigonometric identities, right? So does anybody remember which one sine is, even or odd? It is odd, all right. And odd functions are symmetric about the origin, which means at any point x comma y on the graph, it will also have the exact opposite, negative x comma negative y, right? So if I have pi over 2, 1, then I should also have a negative pi over 2, -1, which I do, right? And that would be true for absolutely any points on this curve. So this is odd, and it is symmetric about the origin. Good times? Had by somebody somewhere? Just not in this classroom? All right. So now, all right, let's talk about some kind of variations that we can have, right? We'll start very small. All we're going to do is multiply this by 2, okay? There's a couple of ways that you can think about this. You can think of this as a vertical stretch, all right? But when we talk about sine and cosine, all right, well, I guess I'll get there in a minute. All right, so really, what is this doing, right? So if we kind of create our xy table again, and it says from negative 2 pi to 2 pi, right? So I'll say, okay, negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so now let's we can think about these since we already marked these down on our last graph, right? 0, pi over 2. All right, so we know that the sine of 0 is 0. What's 2 times 0? 0. So this is still 0. Oh, whoops, sorry. I put that in the wrong spot. All right, so pi over 2, all right, we said when we were just doing sine of x that the sine of pi over 2 is 1, right? So if I plug pi over 2 here, sine of pi over 2 is 1, and 2 times 1 is 2. Sine of pi was 0. Of course, 2 times 0 is 0 again. The sine of 3 pi over 2 was negative 1. So 2 times negative 1 is negative 2. And then, of course, 2 pi, we're back at 0 again, all right, on our unit circle. So the sine of 2 pi is 0. 2 times 0 again is, of course, 0. All right, well, now we can do negative pi over 2. Remember, in terms of coterminal angles, negative pi over 2 and 3 pi over 2 are the same thing, right? So this is just going to be negative 2, 0. Negative 3 pi over 2 is the same as pi over 2, coterminal angle-wise. So it will all look like this. All right, so now if we graph this thing, all right, so of course this will be pi, this will be 2 pi, this would be negative pi, this would be negative 2 pi. I'm not going to write in every little thing. This is sufficient to know that this is half a pi and that this is 1.5 pi. So if we go ahead and plot these points, all right, we get negative 2 pi, 0, negative 3 pi over 2, 2, negative pi, 0, negative pi over 2, negative 2, 0, 0, pi over 2, 2, pi, 0, 3 pi over 2, negative 2, and 2 pi, 0. All right, so if we connect this with a nice smooth curve, it's really hard on this little pen pad, which hurts my heart because on the whiteboard I'm really good at sine curves. On this thing I am not. All right, but you get the point. quite possibly the ugliest sine curve I've ever drawn in my life. It hurts my feelings. I have to try again. Oh, son of a biscuit. It's still terrible. Yeah. Yeah, a little bit. Yeah. Still hurts my heart inside. Okay. Where do we get? Okay. All right. So you guys go ahead and try this one. All right. I'll get you started. Right. I mean, really, as of right now, we're just doing the x and y's. All right. So here we have negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2. What did it tell us to go to? 9 pi over 2. Sweet baby Jesus. All right, so 4 pi and 9 pi over 2. Which one? 7 pi over 2? Oh, 5 pi over 2? Yeah, it's just they kind of go all the odds, right? This is really just 1 pi over 2, 2 pi over 2, which of course reduces, 3 pi over 2, 4 pi over 2, which reduces, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. Right? We're just kind of counting by pi over 2s. All right, so we've already done a lot of these, right? We've already seen all of these. And remember, it's periodic. It's just going to start repeating itself, all right? So, like I said, we've already done these. So go ahead and start those and then just put them on a graph. Yep. It's just 1/2 sine of x, but I will in a moment as soon as I get this. Okay. right, so hopefully we've started to get the hang of this. All right, so negative pi over 2 is the same as 3 pi over 2, which is negative 1, but then when we multiply that by 1/2, we would get negative 1/2. Of course, sine of 0 is still 0, 1/2 of 0 is 0. Pi over 2, sine of pi over 2 is 1, half of that is a half. All right, and then basically we just continue this pattern. So 0, negative 1/2, 0, positive 1/2, 0, negative 1/2, 0. Wait a minute. How did I get messed up there? That's right, because there we go. And then, whoops, positive 1/2. All right, so we've got that pattern going on here. All right, so negative pi over 2, negative 1/2 would be here somewhere. 0, 0, pi over 2, 1/2, pi 0, 3 pi over 2, negative 1/2, 0, positive 1/2, 0, negative 1/2, 0, positive 1/2. And then this will be hideous, of course. Whoa! So there is our curve. All right, so what was the only difference between having a 2 out here and the last one and a 1/2 here and this one? Yeah, the range, right? It just tells me how high and how low I go. All right. And that's actually kind of the definition of the amplitude. All right. The amplitude is the distance from the middle of the graph which I call the baseline. Some other teachers call it the midline. It's all the same thing. To the minimum and maximum values. All right, so basically, if we have some sine or cosine curve here, right, the distance here or here, that is the amplitude. Same thing, this distance here. All right, how do we find the amplitude? It's quite easy, all right? So if we have y is equal to a times the sine of x, all right, the amplitude is equal to the absolute value of a, whatever that number is out in front. And that's really what happened with these last two, well, really all of them, right? So the parent function here is just y equals the sine of x, all right? So since there's no number out here, that's just a 1, right? So from the middle of my graph, which right now is my x-axis, right, I go up 1 to get to my maximum, or I go down 1 to get to my minimum. All right, here, because I had 2 sine of x, right, my a is 2, so the absolute value of that is 2. So from the middle of my graph, which again, for this one is my x-axis, I go up 2 to get to my maximum, or I go down 2 to get to my minimum. And then with the last problem we just did, the a was 1/2, which the absolute value of that, of course, is 1/2, so my amplitude is 1/2. So from the baseline, the middle of my graph, I would go up 1/2 to get to my maximum, or down 1/2 to get to my minimum. And that is what we call the amplitude. Okay. So what is my amplitude going to be here? Yes. All right, it's 3, which means my maximum is going to be at +3. My minimum is going to be at -3. All right, what do you think this negative does out here, though? We haven't dealt one with a negative. What do negatives usually do out in front of graphs as far as transformations are concerned? Somebody maybe tried it. What did they say?
It's going to be flipped.
Yeah, absolutely. All right. It's going to be reflected about the x-axis. All right. So basically, when we're starting from 0 here, we've always been going up first. All right. Well, when our a is negative, it just means we're going to go down first. Okay. So it's really not too, and of course you can always do an XY table, right? So -3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. So again, if we plug -3 pi over 2 in for x, right, that's the same as pi over 2 on our unit circle. So this would be 1, all right? So of course we multiply 1 by -3 and we get -3. All right, this of course is 0, and -3 times 0 is still 0. All right, negative pi over 2 is the same as 3 pi over 2. The sine of 3 pi over 2 is -1. -3 times -1 is +3. Sine of 0, of course, is 0. -3 times 0 is still 0. All right, and then basically we've gone through one full period here, so we just repeat the process, right? So -3, 0, 3, 0, -3. All right, so if we want to graph this thing, all right, so typically what I like to do when I graph these, all right, is I use my baseline and the amplitude. All right, as of right now, all of the ones that we've looked at, the baseline has just been the x-axis. We'll get to when that changes in the future, but for right now, we can just assume that it's the baseline, that the x-axis is the baseline. All right, I like to put dashed lines at my baseline, and then I go up my amplitude, which we said my amplitude is 3 here because my a was -3 and the absolute value of that is 3, and down my amplitude. All right, and then I know basically that every point on my graph is going to be on one of these three lines. All right, so I know that I have negative, and I guess I should mark this. This can be negative pi, 2 pi. Okay. So negative 3 pi over 2, negative 3. Negative pi 0, negative pi over 2, 3, 0, negative 3, 0, 3, 0, negative 3. All right, so there's all of my points. I connect them with a nice smooth curve. And we're done. All right, so the baseline and then going up and down the amplitude, all right, is always, I call them guidelines, right? Because every point that I'm going to put on my graph will be on one of those lines. All right, the period of the sine function, all right? Now, of the parent function, the period is 2 pi. All right, but just like any function, all right, it can be modified, all right, it can be transformed. All right, so now we're going to add to our kind of standard form of a sine curve. Sine, it works for sine and cosine. All right, so now I'm going to say, okay, well, y is equal to a times the sine of b times x. All right, and when we're in this kind of setup, our period, all right, which remember is how often our graph will repeat itself, how long it'll take before it starts to repeat itself, all right, is going to be 2 pi divided by b. So whatever this number is here, all right, you divide 2 pi by that, and that will get you your period. All right, now, although we haven't really discussed it much so far, it's all just kind of been standard, right? All of our little intervals have always been pi over 2, right? So, negative pi over 2, 0, pi over 2, so on and so forth. Well, how we've always gotten that, all right, and those are what are called our intervals, right? The intervals are basically the distance between each tick mark on our curve, all right? You can always find those simply by doing your period, whatever your period ends up being here, divided by 4. Okay, so sketch the graph of y equals sine of x over 2. All right, now we do have to kind of, be smart enough to figure out here that this is really the same thing as the sine of 1/2 x. All right, so what is my b in this case? 1/2. What is my a? 1, yeah. All right, so a is equal to 1. So that tells us that our amplitude is 1. All right, b is equal to 1/2. So that will tell me that the period is equal to 2 pi divided by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. All right, so this is 4 pi. All right, and which also means we can find our intervals. Again, the distance between our tick marks on our x-axis. All right, and that's going to be our period, 4 pi, divided by 4, which will just be pi. Okay, so, and guys, when I have you graph sine and cosine, I'm never going to give you like an actual graph, all right, because it gets really, really messy when these intervals and periods and stuff start getting a little bit funkier, which we'll see examples of that as we kind of move on and get further. It is so much easier to just draw your own graph and your own scale and stuff simply by going by all of this information. So I'll never like kind of give you uh, an actual grid. You'll kind of always want to do it yourself. All right. So here we've got, whoops, x-axis, y-axis. All right, we're just going to 1 and -1 because my amplitude is 1. I always go 4 tick marks to the right and 4 tick marks to the left. That's 2 periods, 1 period to the left, 1 period to the right. All right. Now we won't always start on 0 here. All right. Again, we'll get to cases where that gets shifted around a little bit here shortly. But all right, so here my intervals are now pi, right? So if this is 0, this is pi, 2 pi, 3 pi, and 4 pi. This, of course, would be -pi, -2 pi, -3 pi, and -4 pi. All right, now I said earlier that guidelines can be very helpful, right? Well, we still haven't gotten to anything other than the x-axis being our baseline, the middle of our graph. Our amplitude is 1, which means I go up 1 to get to my maximum, and I go down 1 to get to my minimum. Mr. Crouch? Sure. I do. Sure. Mm-hmm. But oh, Kylie, you need to go. Do you know where Mr. Vincent's office is? Okay. Um, do you know the stairwell in the middle, not the main stairwell, but that one right behind it, like by the elevator? Yeah. If you go all the way down to the bottom, take a right. His office is right there on the right. It'll be the first door on the right. Okay. So we have our baseline, we have our minimum and our maximum values. All right. Now, sine, the only difference between sine and cosine, all right, sine will always start on the midline, on the baseline. All right. So, bam. All right. If your A is positive, which it is in this case, you will go up first. If your A were negative, it would go down first. But then you just follow your pattern, right? It's a lot easier than trying to plug in values every time and getting X and Y's. Of course, if you ever get stuck, you can always do that. So then we try to draw this with as nice as smooth of a curve as possible. Hey, that one wasn't bad at all. Go me. Good times? Had by somebody somewhere? All right. Try this one. So just say, okay, what is my A? What is my amplitude? Right, our baseline is still going to be the x-axis. So we'll go up and down our amplitude. All right, what is my B? That will help me find my period, 2 pi divided by B. Whatever that period ends up being, if you divide it by 4, that will give you your intervals, which is essentially your x-axis scale. All right, so this one's still relatively basic. Right? My A is equal to 1, which means my amplitude is 1. Our B is equal to 3, which means our period is equal to 2 pi over 3, which doesn't reduce any, right? You just leave it like that. Right? And our intervals, you take your period and you divide it by 4. Now, dividing by 4 is the same thing as multiplying by 1/4. So that's 2 pi over 12, which is pi over 6. All right, so go ahead and get some axes here. Of course, our baseline is still the x-axis. Our amplitude is 1, so I go up 1 for my max and down 1 for my min. All right, our intervals we know are pi over 6, so this is 1 pi over 6. 2 pi over 6. I don't care if you reduce those or not. These are just for our own purpose here, right? 3 pi over 6 and 4 pi over 6. And going this way, just the opposite. All right, this is sine, so I start on my baseline. My A is positive, so I go up first. And then I just kind of come up and down the ladder, essentially, right? And follow the pattern going in this direction as well. And we have our, whoa. And there we go. Good times? Great times. That's what I'm talking about. All right. A horizontal translation. All right. Now, with sine and cosine curves, we typically don't call these a horizontal translation. They are more often called phase shifts. All right, so we're going to, and I actually call this the start. Where am I starting my graph from? All right. So now, all right, we're going to kind of introduce a new variable to our standard form, right? So now we can have, okay, well, y is equal to a times the sine of bx minus c. And your horizontal shift, your phase shift, or your start, whatever you want to call it, I will always call it the start because that is where we will be starting the graph from. All right. We simply find that by doing c over b. All right, now do be mindful that there is a negative built into this equation. All right, so it's always going to be the opposite of whatever you see here, right? If you saw like -3 here, then your c would be +3. If you saw +4 here, all right, then your c would be -4. So do keep that in mind. All right, so let's sketch the graph of this thing. All right, so my A is still 1, right? There's nothing out in front of that sign, so that's my A. All right, B is the number here in front of X. When there's nothing there, that is also 1. All right, and our C, remember it's the opposite of whatever number we see here, so it's just going to be positive pi over 3. All right, and before we get started on this, I guess, here, the start, right, which is where the graph is going to be starting, I also like to know where my graph is going to be ending. All right, and in order to find where your graph ends, now I always do this with respect to 2 periods, right? Usually when I quiz you on this stuff, I'll have you do 2 periods of any graph, all right? So I do one to the left and one to the right of my start. So all you have to do is take your start plus or minus your period, whatever your period happens to be. All right. Of course, when you add the period, that'll go 1 period to the right, and when you subtract it, that'll take you 1 to the left. Okay, so our amplitude is just the absolute value of A, so it's just 1. All right, our period, all right, is 2 pi divided by B, Well, 2 pi divided by 1 is just 2 pi. All right, our intervals, which remember is basically our x scale. All right, we take the period and we divide it by 4, so that will reduce to pi over 2. All right, now our start is c over b, which in this case is pi over 3 divided by 1. Of course, anything over 1 is itself. So that's pi over 3. Now to get to the end, I take pi over 3 and I plus or minus the period. All right, now, in order to add fractions, you do have to have a common denominator, right? So 2 pi is the same thing as 6 pi over 3, right? Because 6 over 3 is just 2. So now I can go ahead and do this. When I subtract 6 pi over 3, I'm going to get negative 5 pi over 3. All right, and when I add, I will get 7 pi over 3. All right, now this isn't really going to match very well here, all right, as far as our intervals, all right? So I kind of want this to have a common denominator as well, all right? Well, between 2 and 3, it's going to be 6, right? So this is actually going to be 3 pi over 6. This is going to be 2 pi over 6. And these ones here will actually be negative 10 pi over 6 and 14 pi over 6. And we kind of want all of this stuff to have common denominators. It'll just make it making our graph a lot easier. All right, so we get our x-axis again. Actually, oftentimes, right, especially once you start getting in C's and you start having funky starts, all right, oftentimes you won't even want to deal with your y-axis yet, and I'll explain that in a moment. You always want to put your start in the middle, all right, so this would be 2 pi over 6. You want to go 4 to the right and 4 to the left of that. All right, now the distance between each one of these tick marks is our interval, right? So that's 3 pi over 6. So as I go to the right, I have to keep adding 3 pi over 6. So this would be 5 pi over 6, 8 pi over 6, 11 pi over 6, and 14 pi over 6. Now, if you did everything correctly, it should match up with this end, right? This is where I'm going to end here. 14 pi over 6, it does, so I'm good. All right, when I'm going to the left, I'm going to be subtracting 3 pi over 6 every time. So 2 pi over 6 minus 3 pi over 6 is negative pi over 6. Subtract 3 pi over 6 again, negative 4 pi over 6. Negative 7 pi over 6, and negative 10 pi over 6. Again, if I did it correctly, it should match up here. These two match up with my ends here, so I'm good to go. All right, now, where would 0 be on this number line? Between what and what? Yeah, exactly, right? Between a negative and a positive, right? That's where 0 always is. Which one is it going to be closer to? Negative pi over 6, right? So my y-axis is actually going to be somewhere like here. course, my amplitude is just 1, so I just need to go up 1 and down 1. All right, our baseline still at the x-axis. Amplitude tells me to go up 1 for my maximum and down 1 for my minimum. All right. Now, what we have to be careful here is, did any of my tick marks that I created, did they end up being 0? No. So we're actually not going to be putting a point on the y-axis. Okay. So I start at my starting point, which we know is 2 pi over 6. This is sine, so I start in the baseline. My a is positive. That means I go up first. Back to the baseline, down to the minimum, back to the baseline. Follow that pattern going the other direction. Do be mindful to not put it on the y-axis, right? So we go down to the minimum, back to the baseline, up to the maximum, back to the baseline. And now we connect this with as nice smooth of a curve as we can draw on this thing, and we call it a day. I think that's enough for today. We'll get to the kind of final step of this tomorrow. All right. I posted the worksheet on Google Classroom, but of course, for all of those here, I have a hard copy for you, so you can just have the worksheet. So the assignment for graphing sine and cosine is not going to be on Delta Math, at least today's. All right, it is going to be a worksheet. All right, so I'll pass that out now. Anybody have any questions or concerns?